Imagine your brain is like a city. Inside this city, millions of tiny workers' neurons are constantly communicating with each other. They send signals, make decisions, evaluate danger, remember experiences, and guide your actions. Some areas are responsible for logic, some control emotions, some store memories. But one district is especially powerful. It is called the reward system, and addiction begins there. The reward system exists to keep you alive. Every time you do something important for survival, like eating food, connecting with other people, or accomplishing a goal, your brain releases a chemical messenger called dopamine. Dopamine is not exactly happiness. It is closer to motivation. It tells your brain, that was important, remember it. Do it again. Imagine dopamine like a small golden stamp your brain places on an experience. Each time something feels rewarding, the brain stamps it and says, this matters. Eating when hungry gets a stamp. Laughing with friends gets a stamp. Learning something new gets a stamp. But addiction happens when something hijacks the stamping machine. Think of your brain like a traveler exploring a forest. Normally, to reach happiness, achievement, or connection, you must walk through winding paths. It takes effort and time. Studying for years to build a career. Training your body to become strong. Building relationships through trust. These are long paths. But addictive substances and behaviors are like secret tunnels through the forest. Alcohol, nicotine, drugs, gambling, video games, social media. They give the brain an instant shortcut to reward. Suddenly, the traveler doesn't need to walk the long path anymore. The tunnel leads straight to the reward center. And the brain loves shortcuts. To understand addiction, we must understand dopamine more deeply. In 2010, Dr. Nora Volkow and her colleagues at NIDA conducted brain imaging studies using PET scans to observe dopamine activity in people addicted to drugs. Their research found that addictive substances can increase dopamine levels 2 to 10 times higher than normal rewards. Imagine receiving a small reward for eating a meal. Now imagine receiving 10 times that reward instantly from a drug. Your brain reacts like a city receiving a massive fireworks show. The brain learns quickly. Whatever just happened, it says, is extremely important, and it begins building strong neural pathways that push you to repeat it. Many people think addiction only means drugs or alcohol. But addiction is actually about patterns of behavior that repeatedly trigger the brain's reward system. In 2016, neuroscientist Mark Potenza and colleagues at Yale University studied behavioral addictions such as gambling and internet gaming. Their research showed that these activities activate the same brain circuits involved in substance addiction. The brain doesn't always distinguish between chemical and behavioral rewards. Whether it's cocaine, gambling, or scrolling endlessly through social media, the brain responds to dopamine spikes. It's like pressing the same reward button again and again. The human brain evolved in an environment where rewards were scarce. Thousands of years ago, humans had to hunt animals, gather plants, and travel long distances just to survive. Rewards required effort, but modern environments contain highly concentrated rewards everywhere. Fast food delivers calories instantly. Online entertainment delivers stimulation instantly. Apps deliver social approval instantly. It's like placing thousands of reward buttons inside the brain city, and the brain begins pressing them repeatedly. A famous experiment illustrates this perfectly. In the 1950s, psychologist James Olds conducted an experiment involving rats and electrical stimulation of the brain. Researchers discovered that if electrodes stimulated the brain's reward center, rats would press a lever to trigger the stimulation. But something shocking happened. The rats pressed the lever thousands of times per hour, sometimes refusing to eat or sleep. The reward signal was so powerful that it overrode survival instincts. This experiment revealed something profound. When the reward system is artificially stimulated, behavior can become compulsive. Addiction works in a similar way. But the brain does not stay the same forever. It adapts. When the brain experiences large dopamine spikes repeatedly, it begins adjusting its sensitivity. This process is called tolerance. Imagine listening to loud music. At first, the volume feels intense. But after a while, your ears adjust and the music feels normal. Your brain does something similar with dopamine. Over time, the brain reduces its sensitivity to reward signals. This means the same activity that once produced pleasure now produces less effect, so the person increases the behavior: more alcohol, more gaming, more scrolling, more gambling. But the satisfaction keeps shrinking. The brain is chasing a feeling that becomes harder and harder to reach. Addiction gradually changes how the brain evaluates rewards. Normal activities that once felt enjoyable begin to feel dull. A walk outside, reading a book, talking to friends. These experiences release small amounts of dopamine, but compared to addictive stimulation, they feel weak. Imagine eating extremely sugary desserts every day. Eventually, fruit begins to taste bland. The same thing happens to the brain's reward system. Addiction slowly shrinks the world of pleasure. Only the addictive activity feels meaningful. Another important factor in addiction is stress. In 2014, researchers led by George Koobs studied the role of stress hormones in addiction. They discovered that repeated addictive behavior activates the brain's stress systems, including cortisol and CRF. This means addiction eventually becomes less about pleasure and more about relief from discomfort. At the beginning, people may use substances to feel good. Later, they use them simply to feel normal. Imagine carrying a heavy backpack all day. When you finally take it off, you feel relief. Addictive substances can temporarily remove emotional weight like anxiety, loneliness, or sadness. But after the effect wears off, the backpack becomes even heavier. Many addictions begin as attempts to solve emotional pain. Loneliness, trauma, stress, loss. In 2015, Dr. Gabor May emphasized that addiction often develops as a response to emotional suffering, rather than simply a lack of willpower. When people feel overwhelmed, they look for something that changes their mental state quickly, something that numbs pain, something that provides comfort, something that distracts the mind. Addiction can become that tool. But like using a temporary patch on a broken pipe, the underlying pressure continues building. Addiction is reinforced by a psychological pattern called the habit loop. This concept was studied extensively by MIT researchers Anne Graybiel and colleagues, who examined how habits form in the brain. A habit loop has 3 parts: cue, routine, reward. For example, you feel stressed, cue. You smoke a cigarette, routine. You feel temporary relaxation, reward. The brain remembers the pattern. Over time, the cue alone begins triggering cravings. You may not even consciously decide to repeat the behavior. When the brain associates a cue with a reward, it begins predicting the reward in advance. If the reward does not arrive, the brain creates a strong motivational signal urging the person to obtain it. It's similar to hunger. When your body expects food but doesn't receive it, hunger intensifies. In addiction, the brain expects dopamine. Without it, the brain sends signals that feel like intense desire or restlessness. Not everyone who tries alcohol, drugs, or addictive behaviors becomes addicted. Why? Research suggests addiction is influenced by several factors: genetics, environment, mental health, early life experiences. Twin studies estimate that 40 to 60% of addiction risk may be genetic. According to research summarized by the National Institute on Drug Abuse, some brains are naturally more sensitive to dopamine changes. Others may experience stronger stress responses. But environment also matters. Growing up in stressful or unstable environments increases addiction risk because people may learn fewer healthy ways to regulate emotions. One of the most interesting experiments about addiction involved rats again. In the late 1970s, psychologist Bruce Alexander created an experiment called Rat Park. In earlier experiments, rats placed alone in cages often consumed large amounts of morphine-laced water. But Alexander changed the environment. He created a large enclosure filled with toys, tunnels, food, and other rats. In this enriched environment, the rats consumed far less morphine. The conclusion suggested something powerful. Connection and stimulation may protect against addiction. Loneliness may increase vulnerability. In many ways, addiction is a powerful learning process. The brain learns, this activity reduces discomfort, or this activity produces strong reward, and it repeats the behavior. The brain is not trying to destroy itself. It is trying to solve a problem using the tools available. Unfortunately, the solution creates new problems. The good news is that the brain can change again. The same plasticity that allows addiction to develop also allows recovery. Over time, if addictive behavior stops, dopamine systems gradually recalibrate. Natural rewards regain their strength. The forest traveler begins walking real paths again instead of tunnels. The process takes time, patience, and often support from others. But the brain is capable of rebuilding itself. Many people think the opposite of addiction is sobriety, but some researchers suggest something deeper. The opposite of addiction may actually be connection. Connection to people, connection to purpose, connection to meaningful activities. When life provides genuine sources of reward, the brain does not need artificial shortcuts as much. Remember, the brain is a city. Addiction may temporarily reroute its roads toward a single destination, but cities evolve. Roads can be redesigned. New districts can emerge, and the brain can rediscover balance. Understanding addiction is the first step toward compassion, not only for others, but for ourselves. Because addiction is not simply a story about weakness. It is a story about the brain's powerful search for relief, reward, and meaning. Thanks for watching.